Multiplication of complex numbers. Okay, so welcome to today's class on King Solomon and Picosso. That is algebra, Math 151. And today we're looking at multiplication of complex numbers. Multiplication of complex numbers. We've already started the studies on complex number, and we see a number is complex when it's having two sides. So a number is complex one when it's having the real part, and two when it's having what? The imaginary part. So this describes why we see a number is a complex number, and we say that a complex number is always denoted by the letter Z. So today we want to find how to multiply two complex numbers. So let's say if I have Z1 equal to X plus, so let's say X1 plus Y1I, and I have V2 is equal to X2 plus Y2I. Then how do I multiply these two complex numbers? But before that, you have to take note that when we did the addition and the subtraction, we realized that we are focused on grouping the real part and operating on that, and also to grouping the imaginary part and operating on that. But for multiplication, we don't do that. We do them together. So after doing them together, we will arrive at getting some real part of it, and we arrive at getting some imaginary part of it. So now we go through the same procedure. So to find Z1, Z2, that is their multiplication, a simple X1 plus Y1I multiplying X2 plus Y2I. But you have to take note that I, which makes a number a complex number, is equal to what? The root of what? -1. So therefore, -1 is simply equal to what? I squared. You have to put this in your head, and that will help us do the multiplication and even some other topics like the complex conjugate. Okay. So now if we have this, then we can simply go on. Let's simplify this down. We can get x1 multiplying x2. You can get plus x1 multiplying y2i. Okay, so we are done with that one. We can also have this plus y1i multiplying x2 plus y1i multiplying y2i. Okay, so when we want to simplify this, we get x1, x2 plus x1 y2i plus y1, x2 y1 I, okay, and plus y2 y1 y2 I squared. But take note that we said I squared is equal to what? -1. I squared is what? -1. So if then it's I squared, it's I squared because of this I and I. So if then it's I squared, it becomes -1. So we get x1, x2, plus x1 y2i plus x2 y1 I minus, because this -1 will affect the whole of this, so minus y1 y2. So this I square is what? -1. So it's more or less like multiplied by -1, which will affect this one. Okay. So we get this. Now realize that these two are giving us a real number. But here, because of the I, this will give us an imaginary number. This, because of the I, it will give us an imaginary number. And this is also giving us a real number. So you can group the real part now. So grouping the real part now, we have x1, x2, and we can get minus y1, y2, plus we can x1, y2, plus x2, y1, all I. So we factorize the I out. So when you do the multiplication of two complex numbers, this is what you're expecting to get. And this part, this whole part, becomes the real part, and this whole part becomes the imaginary part. Okay, so I want you to keep this in your head, and let's try one or two examples. Okay. So now, what example one? Example one. Let's multiply z1, which is equal to 3 plus 2i, and z2, which is equal to minus 1 minus 4i. Okay. So we are asked to multiply z1, which is equal to this, and z2, which is equal to that. So now, this is the final thing we are having here. So this is more or less like a formula of the multiplication of complex numbers. So putting this in your head, let's now put from z1, we have 3 plus 2i. So therefore, we have x1 and we have x2. Sorry, we have x1, we have y1. So therefore, x1 here is what? Is 3. Y1 here is what? Is 2. Okay. And from z2, we are having minus 1, minus 4i. So therefore, x2 here is what? Minus 1. Y2 here is minus 4. Okay, so if you have this, it will really help you. So now let's write the equation down. So with the equation, it is x1, x2 minus y1, y2 plus x1, y2 plus x2, y1, all I. Okay, so this is the real part. So let's go. What is x1? x1 is 3 multiplying, what is x2, which is minus 1, minus y1, which is 2, multiplying y2, which is what? Minus 4. Okay, so plus x1, which is 3, multiplying y2, which is minus 4, plus x2, which is minus 1, multiplying y1, which is 2. Okay, when you do this, you bring your I, because that's the imaginary part. Okay, so now that this one will give you minus 3, and this one will give you minus 8. Okay, so minus 2 minus 8 plus. Okay, so this is also minus here. So minus that will give you plus 8. Minus 2 minus 4. So that will give you plus 8. Okay, so you can get this one give you minus 12. And this one will give you minus 2. So therefore you'll be getting 5 plus, which gives minus 14. So therefore it's 5 minus 14i. And this becomes our final answer. So therefore, z1 multiplying z2 is equal to 5 minus 14i. Okay. Let's take another example. Let's take one more example. And let's look at some properties. So with the next example, so example 2, let's say you have z1, which is 7i, and you have z2, which is minus 5 plus 2i. Going through the same procedure, from z1, you don't have any real part here. So the real part is 0, 0 plus 7i. From z2, you have minus 5 plus 2i. So therefore, here becomes x1, y1. So our y1, x1 here is 0. Our y1 here is 7. So here our x2 here is minus 5. Our y2 here is 2. Okay. Let's put the formula there. x1, x2 minus y1 minus y2 plus x1, y2 plus x2, y1 I. Okay, so as time goes on, you should be able to memorize this. So you know that this one, x1, x2, this one, y1, y2. But this one is when you take x1, you have to take y2 plus when you take x, you have to take y1 and add the I to it. You have to memorize it. Okay, so now I'm going to give you 0, 0 times x2, which is negative 5, minus y1, which is 7, times y2, which is what? Is 2 here. Okay, plus x1, which is 0, times y2, which is 2. Okay, plus x2, which is minus 5, times y1, which is 7. Okay, and all I. So when you do this, you are getting 0 here, minus 14, plus when you do this, you are getting 0, minus 35, all I. So therefore, the final answer here will be minus 14, minus 35i. So therefore, z1, z2 is minus 14, minus 35i. Okay, and this brings us to the end of this question. Now there are some properties of complex multiplication of complex number you have to note. And among these properties, or before we come to the properties, you have to know something, that the multiplication of complex number is both commutative and is both associative. The multiplication of the complex number is both one, it is commutative, and two, it is associative. So, one, how does it become commutative? So if you have Z1, Z2, Z1 and Z2 is equal to Z2, Z1. So this is the property of commutativity. And it also has the property of, it's valid for the property of associativity. That is to say, if you have Z1 multiplying Z2 and Z3 into bracket, then you can also have Z1, Z2 multiplying Z3 into bracket. Okay. Again, to the product of two complex numbers also have these simple properties. The product of two complex numbers also have these simple properties. So the product of two complex numbers. So the product of two complex numbers, let's say Z1 and Z2. Now they'll have this property. The property states that the modulus of their product, is equal to modulus of one product, the modulus of one complex number, multiplying the modulus of the second complex number. So now if you take the modulus of their product, that is Z1, Z2, and you find the modulus, it's equal to find individual modulus and multiplying them. Okay. And the second one says that the argument of their product is the same as the individual argument, the addition of the individual argument. So now if you find the argument of when they are multiplied together, then the argument is equal to the argument of their individual one, so the argument of the Z1 plus the argument of what? Of the Z2. And these are the products. So I'd like us to verify the first one, and you can work on to verify the second one, which is very easy. So let's take an example to verify the first one, and let's see whether it is correct. So verifying that modulus of the product is equal to the individual modulus, the product of their individual modulus. Okay, so let's take Z1 equal to 3 plus 2i. That is the first example we did. And Z2 is equal to minus 1 minus 4i. Okay. Now when we did this, yeah, Z1 and Z2 will give you 5 minus 14i. So you can do that when you find the product. Z1 and Z2 will give you 5 minus 14i. So if that is giving that, then you can find the modulus straightforward, and Z2, which is equal to 5 squared plus negative 14 all squared. Yeah, under root. We've already done the modulus, so I think you should get it. And when you do this, you are getting root of 2, 2, 1. Okay. So now if this is the case, let's find the individual moduluses. So therefore, individual modulus of Z1, which is here, that one will give you 3 squared plus 2 squared. And when you do this, you get root of 13. And when you find Z2, the modulus of Z2, that one will give you minus 1 squared plus minus 4 squared. And when you do this, you get root of 17. So therefore, modulus of Z1 multiplying modulus of Z2 is equal to root of 13 multiplying root of 17. And that will give you root of 221, which is the same as the modulus of their product Z1, Z2. The complex numbers Z1 and Z2. So you realize that from here, the first, therefore, the product of two complex numbers is verified. So you can go ahead and do the same, find the argument of them, and you find an individual argument and add, and you realize that you're getting the same angle. Have a nice day for joining us.